Okay, so this is our coding for this lab. Okay, we use this coding to modulate and demodulate the signal of FSK. Okay, for this section, MATLAB code for binary FSK modulation and demodulation. This is the new code for this section. Okay, CLC is used for clear all text from the common window. Clear all is for clear or delete the variable create in workspace. And close all for delete all figure whose handles are not hidden. Then x equal to 011000010 is our binary information in this lab. This is our input for our digital input. Then BP is our bit period, 0.000001. And then display the binary information at transmitter. This part, we will display the word binary information at transmitter in the common window. Okay, like this. And then we display the value of X, the value of input. Then for code number 13 until 30, this is the coding for our transmitting information as digital signal for our code. Okay, so we label the graph as Y for Y amplitude and for X time. The title of our graph is transmitting information as digital signal. Then we use subplot 311, which is we divide the current figure into 3 by 1 grid, and we create the axis in the first position. Okay, next. Next is the new code section for binary FSK modulation. Okay, A equal to 5 is the amplitude of our carrier signal, and then BR is our bit rate. F1 is carrier frequency for information as 1, and F2 is carrier frequency for information as 0. And then for the next code until code number line 55 is our code for FSK modulation corresponding binary information. So we use subplot 312, which is we divide the current figure into 3 by 1 grid and create axis in the second position. We plot T3 versus M. And for the X label, we use time in second, and for Y label, we use amplitude in voltage. The title of the graph is FSK modulation corresponding binary information. Okay, the next code, this is the new section for binary FSK demodulation. Code 61 until 102, this is the code for FSK demodulation. Okay. Then for the result, we do the graph. Okay, for in subplot 313. Okay, so the axis is in the third position. Okay, then the Y label is amplitude in voltage, and for the X label is time in second. The title of the graph is FSK demodulation. Okay, for output, I will give to Malini. Okay, Malini, you can see my graph?
Yeah, it looks like there is a screen. Yeah, the output is visible now. So now I will explain on the output. So the first one, there's 3 graphs. So the first one will be our modulating binary sequence information signal, as you can see. it's the input that we used earlier in the coding, which is 011000010. Okay, that is the binary input. And then the next graph is showing the FSK modulated signal according to the binary information earlier. So if you can see clearly, the FSK signal that we got from the binary signal, it is switching between two different types of frequency. As you can see here at the first part here, the frequency is a bit far away from each other and the other one is quite close to each other, right? So this thing happens because the frequency that corresponds to the zero digital input signal, okay, is according to the earlier part of the signal. As you can see, this is also called as space frequency, the one corresponding to the zero digital. Okay, and then the next part is the frequency that corresponds to the one digital input, is known as the mark frequency. Okay, as you can see, whenever the input signal is high or 1, the signal is close to each other. That's where the switching happens between the space and mark frequency. Yeah, and the frequency that correspond to the one digital or high digital input signal is also, we also know that it is higher than the modulator's nominal carrier frequency. Here, the carrier frequency is not visible, but eventually for the FSK, the carrier signal is still used. So, and yeah, after that, for the third part of the graph, we managed to obtain the FSK demodulated signal. As you can see, we got the same signal as our input binary sequence, all right, 0, 1, 1, 0, 0, 0, and 1, 0. So we managed to get the output as well. And I think that's all for the output part. Malinda, do you have anything else to say?
I think no for now.
So that's all from us, and we have added on the meaning for the coding in our report as well. And in our discussion as well, we have discussed on what are the steps to differentiate between the space frequency and also the mark frequency fully in our report. So I think that's all from us.
That's all from us. Okay, thank you.
Thank you.